So you got compressed working on a string. That feels good for about 5 minutes. Then you look at it and think, okay, but this is just a hard-coded sentence. How do I actually compress a file? Yeah, I had the same moment. Episode 1 gave us the engine, but an engine without wheels doesn't go anywhere. Today, we're putting wheels on it. By the end of this video, you are going to take a real file from your disk, any raw file, compress it with Zlib, write the compressed version to disk, read it back, decompress it, and verify you got exactly what you started with. The full round trip. Welcome back. This is episode 2 of Zlib on Linux. If you missed episode 1 where we covered installing and writing Zlib and writing your first compress call, go watch that first. You'll need those 3 minutes. I'll wait. Here's what we're dealing with. In episode 1, we compressed a string literal, 42 bytes, hard coded. See right there in the source file. That's not real life. In real life, your data is in files, log files, config backups, access for a game, a CSV export that's 200 megabytes and growing. You need to get rid of that data and compress it and save the compressed result somewhere you can get back later. That means the file input output, fopen, fread, fwrite, the whole C standard library stack, working alongside Zlib. But here's the most important thing to understand. Zlib doesn't know about files. Zlib does not open files. Zlib does not read from disk. Zlib works on buffers, raw bytes in memory. Your job is to bridge. Read the file into a buffer, hand the buffer to Zlib, take Zlib's output buffer, write that to a new file. That's the pipeline. You are the glue between the file system and the compression engine. Let's break down let's break this into 4 stages. Write these down. Stage 1, read. You open the source file, figure out how big it is, allocate a buffer exactly that size, and read the whole thing into memory. Stage 2, compress. You call compress bound on that buffer size to get your destination buffer size. Allocate it, then call compress. Stage 3, you open a new file. Let's call it with a .0 extension and write the compressed buffer to it. Stage 4, verify. To prove it actually worked, you read the whole .0 file back. Call uncompress and compare it against your original. If stage 1 for all pass, you've got a working file compression pipeline. Think of it like a shipping package. Your original file is the item, the buffer is the box, compress is the shrink wrap machine. It makes the package smaller. Fwrite hands it to a shipping company, and on the other end, uncompress wraps it. You never hand a zero file path. You hand it the contents of the file already loaded into memory. That's the mental model that quits for most people. Let me show you what this looks like for real. I'm going to write a program called file compress.c. We'll walk through it section by section. So far, same as episode 1, but now file size comes from actual file, not string weight. This is the new part. We build the output function. Hello.text comes hello.text.zlib and write the compressed buffer to disk. The percentage printout tells you how it worked. A text file might compress to 15%. A JPEG or PNG already compressed, probably close to 100%. That's normal. Compile it. Now test it on text file. Now test on text file. You'll see the amount of bytes and the compressed bytes. It verifies correctly. 12,000 bytes down to 2,000, or 1 byte down to 60 bytes. If the data is identical to the original, memory comparison doesn't lie. That's a real compression pipeline under 60 lines of C. Now, if you're wondering about large files, do I really need a 200 megabyte file into RAM all at once? The answer is non-production. For huge files, you use ZOS stream API. Deflate and inflate, which process data in chunks. We'll cover that later in the series. But for files under a few hundred megabytes, the better buffer approach works fine and is way easier to understand. Get this working first. In episode 3, we'll take this to the finish line. We'll wrap this pipeline into a proper command line. So you'll take ./decompress myfile.txt or ./decompress myfile.txt.z. A real way to you build yourself. We'll add product feedback, error handling, and comments to something you can actually use. If you had a save file or got stuck on the buffer allocation, I want to drop a comment. What tripped you up? What file type did you test on? I read every comment and it genuinely shapes where this series goes next. If this helped you, hit like and subscribe with the bell if you want episode 3 tomorrow and draws. Thanks for watching. Catch you next time. Bye for now.